Good afternoon, class. We are going to start the PLC lab number 2. Let me show you where you could find the lab sheet to present this lab. Especially using this lab sheet, you have access to all the resources that you need for this specific lab, in resources, tools, materials ahead of time. Also, it's a guide for you when you are delivering this lab. So in order to do that, to get access to this lab sheet, you have to go to the Unify. On Unify, go to Departments, Education, Electrician, Technician, Diploma, ET Curriculum, the 2020 edition. We go to the 180 Programmable Logic Control, Lab Assignment. This is the PLC Lab 2. Okay. PLC Lab 2. Binary logic programming. Okay, and these are the objectives. So this is PLC Lab 2, binary logic programming. So define and describe a PLC and compare it with the hardware systems. Describe and explain the function of several PLC hardware components. PLC hardware components. Describe several number systems. Describe and connect diodes, describe and connect light emitting diodes, and describe how to connect silicon control rectifier. Okay, equipment, PLC, a computer system. Okay, so that is what we need. PLC click and computer system. This is the PLC click. Okay, so this is my CPU, PLC CPU. It's a computer by itself. It has its own CPU, central processing unit. It has its own memory, random access memory, read-only memory. It has a communication port used by this CPU to get connected with the regular computer system. It has I/O devices. The input, interfaces, I/O interfaces. The input interfaces are used to collect information from the external world, and the output interfaces to send information to control electrical devices, such as electrical motor contactor coil or lighting system contactor coil. Okay, and the input are represented at the software level with a letter X, the output letter Y. And I forgot to tell you that as a computer system, it works with DC, so we need a power supply that get 120 volts from the outlet and reduce it to 12 volts, 5 volts, and convert it to DC, from AC to DC. Okay. Also here we have a light set of light with push button as a part of the trainer. Okay, and this light all of them work with 24 volt DC. Okay, and these push buttons are similar to the push button used on the push button start-stop push button station. Okay, let me start the program. Okay, so I will use, let me minimize this or close it. I go to the click programming software, okay, and I click next, and I close this, and start the project. And this is the number that is print. It's print at the top of the PLC, CPU PLC, this number. This number is right here. So I will select that number. Click OK. Okay, now I will create a binary So I insert here. I go on instruction, normally open. I will select X2. Keep in mind the X2 use negative logic, okay? And it's look open at the software level, but it's closed at the hardware level. Now, I select another input in series with the first one, which is, and this is known as an unconditioned. Both of them should be closed to have an output. My output will be, I go to instruction, out. So click on this menu and I will select C1. And right here, I will create a latch controlled by C1. So right here, I go to edit, line, click OK, hit on the arrow, and hit escape. And right here, I go to instruction, normally open, and I will use C1. Okay. It's a binary. When C1 become active or 1, this C1 will be active or logic 1, holding this connection from the left to the right. Okay, and don't forget X002 is using negative logic, which means that it's open here, but at the hardware level it's closed. And right here, I will simulate. Look at this. I will use C2. Let me use C number 2, control number 2. I make a mistake and let me cut this, and it should be normally closed. Normally closed. C2. Okay. Right there, and on the second section, okay, I have X2. I will use X002. And then here I will use X003. X003. And my output will be C2. Normal, my output, but the instruction will be C2. Control 2. Okay. And then I create a latch to retain this connection after I press X003. I will go to edit, line, and then OK. Click on the arrow, click on the arrow, click on the arrow. And hit escape on the blue dot. And here I insert an instruction. Normally open will be C002, my binary latch. Okay. But just one of them will be working, so I will use here normally close. That will be controlled by control 1. And to visually look at this, so we are going to have C1 normally open, C001. Okay. When we come through, I will have an output here. I select an output, it will be letter Y 001, which is the green one, the green light, and C1. Let me fix this. C1. Okay, and right here I will have the output is an output SLN12, which is the red one. But I will change this. Cancel this. Cancel. This will be normally closed. 001. Okay. So and right here I will have normally close C002. The output will be Y 003, which is the yellow one. And then here, normally open, C002, normally open, and the output will be here, output, menu, the number 4, which is the blue one. Now I will write this into the, go to PLC, write into the PLC, write the program into the PLC. Oh, I mistake. I have an error. I didn't include the end. Go to instructions, select end. Now go back to PLC, write the project into the PLC. It will be a new project 105. Okay. And the software is asking me to run this. The PLC CPU got back to stop to be able to write it. So now will be asking me to go back to run to test this. You see? Okay, so what is happening here? Look, just analyze this. Okay, when C1 is not active, this is closed. When C1 is not active or logic 0, this is closed. This is through because it's normally closed. And I have an output here, which is the green one, the green light. Okay, and when the C2, control 2, is logic 0, this is closed. It's closed. It's normally closed. It's closed. It's not activated. It's closed. It's true. So I have a logic 1. The light is on, the yellow one. Okay. So and C2 is open because C2 is not activated, so I don't have output here on the blue one. But if I hit X2, I will hit X001, this will be closed. This will become active. This logic 1 will hold and latch this one. So C1, this will be open, it will be false, this will be logic 1 or through, and then I have an output on the blue one, the red one. Let's test it. X1. X1. Okay, so now, if I press down X3, so C1 will be deactivated, no, C3, X003, C2 will be logic 1 activated, will open that one, turn off C1 will be 0, logic 0 or deactivated, C1 over here normally open will be closed, and this light will be on, but the other will be off. Okay, let's press X1. I'm sorry, X2. Yes. X1, X2. Now, X3. X3. So, look, X1, X002. Okay. Now I close X1. Okay, so that is the logic that we have. Okay, keep in mind, so before I save it, I will go and stop the energize this, go to monitor, status monitor, now 5, close the project, okay. And that's it, that is what I have for today, guys. Thank you.